microrecycling science unlocks valuable resources. VEENA SAHAJWALLA, UNSW, Australia.
On the 9th of November 1989, I remember this strong new feeling of hope, inspired by people's passion to create a better world.
Thank you very much, and you're probably wondering why I'm so passionate about waste. I suppose I wanted to begin my journey going all the way back to when I was growing up in Mumbai, and when you actually get to see waste firsthand on every street corner, you actually look at also, more importantly, not just the waste, but the people who have to work under those circumstances. And the fact that they provide such an important service to our society, the fact that they work relentlessly, and in most cases, obviously don't get paid their fair share, their fair dues in terms of their earnings. So therefore, their livelihood actually depends upon their ability to work under these absolutely horrifying conditions. But really, does it have to be that way? It doesn't have to be this way. Why do they actually do this? If you look at some of these horrific images of burning of circuit boards that are present in our electronic devices, the reason why this is happening is because they're actually looking out for those valuable metals. And by burning plastics, they can then access the valuable metals. And of course, in so doing, that has an effect on their well-being, as you can appreciate, from a human safety point of view, from a human dignity point of view. This is simply not something I was personally comfortable with. And back when I was growing up in Mumbai, it was just something that I felt that I had doubts about whether we were being fair to everyone, people who were providing this important service, collecting waste, and actually enabling everyday life to continue. So really, does it have to be this way? Can we not think about what are the alternatives when it comes to processing different types of waste materials? What we are looking at is the possibility that you could imagine that where waste is being collected in different parts of the world, it could actually be seen as a really useful resource. So if UNEP has already defined that there are billions of dollars worth of resources and basically potential available to us, then we should be looking at that as an opportunity. But equally importantly, not just an economic opportunity, but rather an opportunity where we can improve the livelihoods, improve what human beings can actually look forward to a future. So by breaking down that wall of waste, we're actually creating a whole new hope and looking towards a future where indeed people are not only looking at technologies that deliver economic value, but indeed people are looking at technologies that are safe, that are sustainable, that are good for our health and our well-being, and of course, importantly, good for the environment. So is there an opportunity for us to achieve that? No matter where you look in the world, the fact that you've got from Australia to States to all over the world, our ability to actually tap into these resources. Yes, there are some parts of the world where we might have more amount of these types of waste, per individual, because we, of course, are looking at where technology and where the digital disruption in the world is actually taking us. We have to stop and ask the question, will the hardware, will the metals, for example, that we need to make those devices, will that again be available for everyone to tap into? How are we going to make sure that those metals are indeed going to be affordable? So the question that I would put to you is, what about material security? Do we actually have the ability to tap in to these types of waste resources and utilize the valuable, the fabulous, beautiful metal alloys? And I would say that it is actually possible to imagine a scenario where we could be taking our phones. And in fact, I'm going to put to you that just between all of us here, where we're looking at about 750 phones that are present in this room this morning, we've got the ability to actually take all of our old broken phones and tap into creation of new, really functional, fantastic metal alloys. And there are just some examples there where you can go back and look at the value that these metal alloys actually have in the market today. So then the question would be, is it possible that we might be able to create a future where everyone on this planet, whether it is our small communities in remote areas, whether they are disadvantaged communities, is it possible for everyone to actually be a part of this whole new fabulous future economy, which allows us to tap into the economic value, but also deliver material security in a safe and sustainable manner, where those waste warriors, no matter whether you're in India or in any other part of the world, are actually earning their fair share and living under safe working conditions that we all take for granted. So indeed, what I'm putting to you today is microfactories that we've developed at UNSW that builds on the innovation, the new science of recycling, which we're calling as microrecycling, allowing us to combine different elements in our phones and indeed convert them into valuable metal alloys, these fantastic metal alloys. So what I'm going to do is I'm going to actually put it to you that let's start the journey right here in Berlin today. And I'm going to take help of Sebastian, if that's okay, in saying that I might begin. He's very kindly offered that as part of our work with our microfactories, that he's going to actually give me one of his old phones. And we might just be able to try that if we start the journey today. I don't know whether he'll agree, whether he'll say yes or no, so he's not too sure, but I think he might be part of this whole experiment. So I think, Sebastian, I'm going to take your phone off you, and I'll be able to tell you what we've actually made from it. So not to worry, this is the first one that we're collecting. Remember, 750 mobile phones, and we're going to be able to produce this incredible value for our society, for everyone on this planet. And that's the key message here. Can these microfactories, can this science that we're developing enable us to tap into the value? So yes, you might have heard, oh, there's a lot of gold in different types of devices. But it's not just about one precious metal. It's about a whole range of valuable materials, engineering materials that are needed to actually perform and do a fantastic job. And then it's not just about metals. Actually, if we can show that those plastics can actually be converted into valuable filaments that then can be used for 3D printing. Imagine if you are located in a small remote community where you actually could not afford to set up large factories. What would you do with these old devices, your old printers? Well, you could actually set up a microfactory. You could indeed produce these types of products, and you might well be able to make high-performance manufactured product. Imagine manufacturing happening in that way in the future. For us, that's really the dream, that we want to be able to take the solution, microfactories, to where the challenges are. So whether there's a stockpile of circuit boards or a stockpile of old printers, what we are basically showing here is it's possible to go on a small scale in microfactories where we convert those types of circuit boards, for instance, in this case that you're seeing, into valuable metal alloys. And the fact that it's possible to do that in a microfactory, and we can still create high-value, high-performance materials, whether they are metallics or whether they are plastics, what we are actually showing is it's possible now to, in fact, link the ability to use microrecycling science to actually show the functioning operational microfactory, which we have at UNSW in Sydney, and to be able to create these marvelous materials that indeed our society depends on. So when we talk about a whole new digital future, this is what we need. We need the materials that will make it happen in a way that it is affordable, it is safe, and it is sustainable for everyone on this planet. So there are examples and so many different examples of so many different types of devices and materials that we've shown is possible to be able to be regenerated from different types of end-of-life electronic products. And that then tells us that the whole notion of microfactory, the ability to, at the micro level, create these incredible alloys where you might have different combination of elements which can then be customized and producing what the end user might want. So the fact that we can take disposable batteries and use that as a source of producing zinc oxide is a classic example of how a really useful product like zinc oxide can in fact be produced from waste. And not just because we have to recycle, but because we can actually produce this type of product of high quality. And I think that's the key. The ability to make products of high quality from waste shows that recycling should not be just seen as an environmental solution. It should be seen as a pathway to create and build new economies. And it should be created as a pathway for delivering on material security. What have we achieved in the last decade at UNSW in Australia is we've shown, for instance, that we can take waste tires. Now, again, here you can picture in so many different parts of the world, tires, when they burn out of control, just like the images we saw of plastics earlier from our circuit boards. We've got a problem, a massive humanitarian problem, because they're not going to stop burning. They're going to create pollutants. They're going to create toxins, which is going to have an impact on our health. What we have done, in fact, and you will see on these images there, that we've shown that it's possible to actually not only use tires in the process of making steel and commercialize this technology, and of course what we have shown globally with this green steel technology, that we have recycled millions of tires in the process of making steel. But here's the icing on the cake. The actual steel making process efficiency has gotten better. We've achieved better outcomes from point of view of achieving a better steel-making process because we've actually reduced the consumption of energy. We've reduced the consumption of coke and coal-based processes that we have in these types of systems that normally are taken for granted. What these images are basically showing you is that the reason why rubber tires have performed so beautifully is that you see these tiny little bubbles on the images. And those tiny little bubbles in those videos actually show you that you've got a technology that actually works far better than what conventional technologies that use coal and coke have done. So who would have thought that you can take waste resources and you can then deliver a solution that actually works better than conventional materials? And that's what I want to actually put to you, that it is possible, and this is what micro-recycling science is showing, that it is absolutely feasible that we can indeed create solutions using end-of-life waste products that might surprise us, where the science might actually show us something that we had never expected before. And for us, that's really what we want to do this for. We want to be able to show that it is very much about creating solutions. Microfactory is a technological solution that still has to build on a whole new science, and a science of hope, where we can actually create new materials, new products, by a combination of different types of end-of-life products. So whether it's a combination of taking nickel from our nickel metal hydride batteries and combining that with copper that comes from our circuit boards and creating copper-nickel alloys. Again, an example of a really expensive alloy. But imagine our waste warriors being able to do that in a microfactory. And that empowerment of people who can then see that their role on this planet is not just about collecting waste and cleaning up, but it's actually about creating valuable materials. So I would like to say to you finally that the call for action, from my point of view to all of you, is very much about creating and thinking and asking questions, and asking the questions that actually allow you to indeed empower all of us on this planet and of course, come up with a solution that ultimately delivers a better planet for everyone on this world. Thank you very much.